Hi, I'm Derrick Jensen. This is Resistance Radio on the Progressive Radio Network. My guest today is Monica Gagliano. She is radically transforming our perception of plants and more generally nature. Inspired by her personal encounters with nature and indigenous elders from many parts of the world, she has pioneered bioacoustics by demonstrating for the first time that plants emit their own voices as well as detect and respond to the sounds surrounding them. She's extended the concept of cognition to plants by demonstrating experimentally that plants can learn just like animals do, reigniting the discourse on plant subjectivity and ethical standing. So thank you so much for agreeing to be on the show.
That's all right. Thank you for having me.
So can you start by telling me and telling the audience a little bit about your experiments on plant learning, like the one with the mimosa or whatever other ones you want to talk about?
Yeah, no, that's great. The mimosa is the first one, so I guess it's a good start. Well, I guess the idea in itself came from my own little excursions into the world, the real world of people in various countries, and to realize that in their private life, when nobody's really listening, everyone tells you that they have a really beautiful relationship with plants, and most of them would actually use the word like, oh, I know that my plant knows. I know that my plant is listening. I know that, and although this sounds very anthropomorphic, we actually, as humans, have done this, have opened and maintained this discourse with the veggie world for a very long time. And in fact, when I travel to places like South America, North America as well, your own country, and Asia, and of course in Australia, the tradition is really strong as well. Pretty much everyone has this discourse, and it's been going on, as I said, for millennia. And it's a relationship with these others. And a lot of them consider this relationship with others as other intelligent beings. And of course, intelligence is a loaded word because we attach very specific concept to it. But it's also opened up the question for me of, well, let alone intelligence as such, but learning, which usually we consider as a form of intelligent behavior. Well, can we look at that specific example of behavior? And of course, in the literature, the scientific literature, people have used the word learning with plants before. So I actually thought I was going quite safe. And but the difference was that usually learning was associated with innate behaviors. What that means is that the plants have got some genes that get triggered and they automatically respond. It's like a reflex rather than something more acquired. And the truth is that, of course, animals have that too. We also have that. And thanks God, because otherwise we wouldn't be able to learn anything. But we also know that we send our kids at school because we know that they can acquire new information, new behavior, new things just by being with others that have done it before or observing others doing things. And so I was wondering whether plants could actually exhibit that kind of learning, which is really, when we talk about learning in animal, that's what we refer to. And we don't even need to specify whether it's innate or acquired, because it's automatically sort of assumed that, a chimpanzee can learn to use a new tool. Oh, wow, it's something that it didn't do before and now it can. So that is the kind of learning that I tested in plants, not the fact that they got some genes that code a specific response and they would do that just as a machine could do, just like your computer could do every time you press the button turn on. And because I felt like it was a little bit unfair to not even test that and assume that they can't do it. And of course, as often it happens in science, it's not so much the experiments done, but it's more daring to ask the question that opens up the floodgates. And that's exactly what I did with my colleagues in Italy and in Australia. It's like, well, do we actually have the courage to just ask the question properly and apply the same sort of empirical frameworks that we have available that is being, fine-tuned so well for animal studies in all sorts of animals, and just see if it applies to the plant. And that doesn't mean that the plant needs to behave like an animal, but it's just like, can you show us something more than what our limited understanding has shown us before? And so we put the plant to the test, and mimosa was selected because it's a really responsive plant. I don't know if everyone is aware, but it's also called touch me not, and it's got all sorts of funny names. And the idea is that it's a plant that when it's touched, it closes really rapidly the little leaflets. And then it actually then droops down the entire little branch with the leaf when it's really like, okay, I'm going to pretend that I'm dead here. And the idea is that it's doing that to sort of mislead potential predators, possibly by looking smaller than it is, or possibly by looking not as healthy as it really is. That one, again, needs to be tested properly as well. But so that was a perfect model for us, because it was something that allowed us to observe a behavior as we would do for an animal. And then I followed the rules that we use for testing this kind of question in animals. And the type of learning that we looked at is, well, generally is considered in many of the reviews is always termed as the simplest form, but there is also quite a strong agreement that simple is nothing to do with this kind of learning, and it's simple just because we don't really understand how it works. So we define it simple because it sounds like, yeah, we can deal with this. And but yeah, habituation is the name, the technical term, and basically is what we all do when we find ourselves in a new environment. We look for the new cues, and when there is a lot of noise, say, in a new environment, you will be really attentive and really alert to all of the new noises. And then it will take you probably a few minutes before you're like, all right, so half of those noises are absolutely meaningless and irrelevant to me. And you literally shut them out. You don't hear them anymore.
So it'd be kind of like
if my dog.
It'd be kind of like if
I can hear every time.
It'd be kind of like if say you're in a strange place and you hear a gunshot and you'll pay attention to it, but if you hear an air conditioner, you would quickly tune that out.
Exactly, and that's our form of, like, it's exactly what we're doing. It's like habituating to the noise that it could be potentially dangerous, but it's not. And we realize that through experience. So it's not about having it coded in our genes or responding automatically. It's just about experiencing something and making a sort of informed decision. You work out what the air conditioning is doing, you realize that it's not going to kill you, and you move on. And so most animals do that, and what we've shown was that plants do that. And it's not just a matter of like because the original experiments done on this, because of course, as always in science, you have those that have tried before, and unfortunately, because of the technical method that we had available, and even the historical background that we had available, maybe it wasn't obviously the optimal way to test things. And so habituation was attempted. The test for habituation in a plant, in mimosa in particular, was attempted before, but often people would cut the leaf, put it on a petri dish, put it in a petri dish with water, and then, release little electrical stimuli or touching it. And a few people have asked me, why did you not do it that way so that you could have eliminated any other potential confounding blah, blah, blah on the response of the plant? And it's like, the plant is a plant as an entire organism. And so I am interested in the fact that there are other things going on with the plant, because the plant, the leaves don't live in isolation. They live as part of a being. And I was like, I don't know, do you think that a mouse or a human being with a leg cut off would behave the same way as if it was not? And I know that sounds pretty drastic, but really it's pretty much the same. So yeah, and we put the plant to the test, and what the beauty of this work is that if you're allowed to the natural world in particular, if you allow it to show you, it will show you what it can do. And you just need to be there and be open to allow it. And so the plant was pretty amazing because within literally a few seconds from starting the training, which consisted in a little drop-in mechanism, so I created this vessel that would just fall literally with gravity, but is a controlled fall from a set altitude, which is 15 centimeters from the plant, and it falls along a little stick, a little rod, and when it lands on foam, so that the drop is actually contained, and the plants, of course, all of the plants close their leaves immediately because, of course, it's the first experience and you don't know what it is, and that is the safe thing to do. But then within seconds of doing this, the plants realize that, oh, actually, nothing is happening after the fall. I'm not dying, nobody's attacking me, nobody's ripping me apart, maybe I just won't worry. And that decision is actually a very important one because when the plant, in this case, when the mimosa decide to not close the leaves because it's useless, it's not meaningful closing them, it's actually gaining time to feed on light, which it can't do as efficiently when the leaves are closed. So there is a sort of a trade-off. You need to find a balance between, should I defend now and protect myself when it's necessary? Or should I just ignore this because it's a waste of time, literally? And should I just keep feeding? And, of course, keep feeding means like keep the leaves open and photosynthesize. I don't know if that explains exactly what I did. No. It was a long detour, I guess.
No, it's great. It's so basically that would be like a human being deciding whether, if you're in this strange place and you hear this sound, whether you should continue going about whatever it is you're doing or whether you should hide in the corner and hope that nobody sees you.
Exactly.
And so
exactly. We do this all of the time.
So you would drop the mimosas and about 15 centimeters, and they would close because that was a new thing, but then they would open up again. But then, and maybe you said this, but I didn't quite understand. So didn't you say that then you would keep dropping them over time, and they would learn to not pay attention to the drop at all, so after a while they wouldn't close at all?
Yeah, that is correct. And that was the thing for us. It was like, I was the one doing this, and you drop this plant and you would think that it should close because 15 centimeters, if you imagine that you are holding a little pot with a plant and you physically put your hands above the ground 15 centimeters, it's enough to create quite a bit of a shock. But if you know that it's not important, then you do ignore it. And yeah, I was doing what we call a train, which is like a successive drop of 60 drops. And within the first one or two, the plants would stop responding. Now, the important thing here, and this caused quite a bit of discussion in Vancouver at the conference that Michael Pollan reported about, because, of course, you could just say, oh, the plant is just tired. Something inside the plant has just, been overwhelmed. And imagine, if we take it back to humans or animals, it's like, when the stress gets so high, you become totally overwhelmed by the situation, and you actually freeze. Most of the time we freeze because we're so overtaken that we can't do anything. So that was the argument, I guess. It was like, can the plants just been overwhelmed and the energy of the plant for responding properly to the environment had been just frozen? And so there is a test that is done in animals, and it's called dishabituation, which means literally you're giving something in the middle of your training, so you're providing the stimulus that the plant is learning about. In the middle of that, you drop in a stimulus that is new. It's very similar, so in this case would have been a mechanical stimulus in nature, and It's very similar in type, and it's very similar also in the severity of it. And what I did, I put the plant on a shaker plate, which is the one that we use in the labs for shaking chemicals and all sorts. And I gave that as my sort of alternative stimulus. And this stimulus, of course, is given only once. And the idea is like if the plant is totally overwhelmed and everything is frozen, it would just not respond anyway. So if the plant is stopped closing the leaves, you put them with a new stimulus, the plant will keep having the leaves still not closed because it can't close them, not because it's choosing not to close them. And but if the plant, as it should, given there is a new stimulus and it doesn't know what the consequences are, if the plant does close the leaf, then it's not exhaustion, it's not overwhelm. It's like the plant simply is selecting what to respond to. And a new stimulus, you should close your leaf if you're a plant, because you need to first decide whether it's something to worry about or not. And I'm sure that if we would have used then that stimulus as our sort of habituating stimulus, and we would have presented it more than one time, then I'm sure that the plant would be like, okay, this is another one of those that I don't have to worry about. And then you present again the habituating stimulus, so the one that you train the plants for. So I dropped them again, and they really started not closing their leaves, showing me that, okay, so you presented me this drop, and I didn't know what it was. Then through experience, because you presented it to me repeatedly, I learned that this dropping is actually meaningless to me, and I should ignore it. Then in the middle of that training, you gave me a new stimulus that I've never seen before. So because it's a new stimulus, I'm going to close, just to be safe, better than sorry. And then you present me the stimulus that I remember I just learned about before. And therefore, I know, I made already my decision that this stimulus is not important and I'm not going to worry about it. And that is exactly what the plant did.
So, and you said that they would remember over time that if you did this again several days later, that the plants would remember that the stimulus was not something they needed to worry about.
Yeah, that is absolutely correct. And actually, in the final paper, we decided to not present the entire data set, because in the literature for animals, especially, clever little things like bees, often we talk about long-term memory if the bee can remember like 48 hours later. So I thought, okay, I'm just going to retest to say 3 days later, just to be really evil and not giving them a chance. And it was quite surprising because I did retest them 3 days later, and they were just performing as if I just did it. So I was like, they still remember too well. Let's give 6 days later. So I went back, and during this time, I was in between. I wasn't disturbing them at all. So they were just sitting in their little pots under the lights doing their thing. Then 6 days later, they still remember absolutely well still. And I was like, oh, no. So either I'm going to run out of time, or what am I going to do to test this? And so because they were performing so well, I had to make it a little bit harder. And so what I did, I divided the group in half, and I kept some of the plants under the same condition that they were before. The initial experiment was set up so that there was already two groups. One group was under really abundant light, and the other group was under a light condition that were like a little bit less optimal. And the idea was that, as we've seen for animals, plants, if they behave like animals do in terms of decision-making, and if the same rules sort of apply, then you would expect, if they learn to learn faster, where the environment demands it more. So under a more less benevolent condition, you would be quicker at learning, because if you make a mistake, it will cost you a little bit more than if, say, in the case of the plant. If the light is abundant, who cares whether you close an extra time? There is plenty of light anyway. But if the light is not abundant, then you need to really be careful when you close and when you don't, because if you make too many mistakes, you are reducing your opportunity to feed, basically. So what I did in relation to these was that we decided to, after 6 days, they were too good at that job, so we decided to extend it to another 28 days. And what we did is, like, for each light group, we divided the group in half. One half would stay exactly in the environment where they got trained in the first place, and the other half would be moved to the other environment. So the plants from low light, half of them went to the high light environment, and vice versa. So the plants from the high light, half of that group went to the low light. And the idea was, well, in nature, the environment changes all the time. So it would be important, if you're learning, and if this is really important to you, then you want to remember regardless of what's happening around you, because some skills are important regardless of whether there is lots of light or low light. And if you learn them once, you better remember them. So we tested them after 28 days, which was a really long time, but I thought, well, we need to give them time to realize that they're in a new environment, and then see if the skills that they learned in the previous environment are still useful in the next environmental scenario. And of course they are. And of course they remembered. And they remember really well. They remember actually better than I expected, because their responses didn't really change so much, but more plants were consistently behaving and responding the same way. So in the group, most of the plants were doing exactly the same thing as each other. While in the beginning, as you can imagine in a classroom at school, in the first year, you probably have a lot of diversity between how different kids learn. But then as the learning progresses, the class sort of become more unified, and you would expect that there are always some that are sort of a bit better than everyone else, and others that are a bit less better than everyone else. But in general, the class will consolidate, and that's exactly what the plants were doing. It's like the variability around their responses shrunk considerably, and so they were all performing better in that sense.
And it also means...
And 28 days is a long time to remember things.
Yeah, I was thinking, I am to the age now where I have to write anything down to remember anything at all. So to remember something for 28 days is quite extraordinary.
Yeah, I always make the example, like, do you remember what you had for dinner a week ago?
Right.
And most people be like, and well, the plant does, and he actually remember what he had a month ago.
And so what are some of the other... Oh, and also, another thing you said is that there was a variability in response. So some plants also, they're not even... It wouldn't be fair to think of them... They are as diverse as humans or anybody else would be, in that some learn more quickly than others, too.
Yes.
So,
yes, you would expect that, and that's, I think, I don't know, I guess, I'm not a real sort of lab person, in the sense that I'm an ecologist, and that means that I'm interested in the relationship between the organism, whatever the organism is, and its environment. And that is actually a really big difference between ecologists and biologists. Biologists have a tendency to look at the organism in separation from its environment. And often they do that in petri dishes and labs. And usually the conditions in the lab are so removed from the original environment that what the responses that they're measuring are very unrealistic in terms of what the animal or the plant or the organism would do in its own environment, in its own private life. So it's just a different perspective, a different kind of question addressed in different areas of science. But because I'm an ecologist, dealing with the variability that we always observe anywhere we go in the environment is almost part of the deal. And it's actually quite funny because I never realized that was such a big deal for biologists, because it's quite funny when you work with a physiologist or any of those guys, they'll be like, yeah, but look at all this variability, there must be something wrong. And it's like, no, that's exactly what it's natural. And what we do in the labs, we shrink that variability to a level that is not there, or it's so minimal, because that is what we are interested in, because we're asking different questions. But it's actually the variability in nature that allows the entire Darwinian theory to make sense, because without variability, evolution cannot operate, because you need differences between traits in a population of a plant, of an animal. You need differences, and some individuals perform better and some others don't so much, because they have different characteristics. And of course, it's very complex, because it's not just one particular trait, but it's like a combination of traits interacting. But that cocktail of variability makes nature so interesting and so diverse and amazing. Otherwise, can you imagine if there was no variability, we would have all of the things would be just the same, and they would never change.
Well, sadly, if this culture has its way, that's where it will end up.
Well, that's exactly what humans are doing, are reducing the variability, not just the natural variability, but, many of the anthropologists. Like, I remember Wade Davis wrote a beautiful book on I think it was titled The Wayfinders, and of course it's on cultural variability, and now, we have so many different ways of expressing our perception of the world, and that cultural variability, or diversity, I guess is a better word in this context, is so crucial to survivorship of, humanity, because it's our raw material for evolution. Otherwise, we're shrinking ourselves into a bottleneck, and that's why the way we're going at the moment is not entirely ideal.
Yeah. People ask me all the time. I'm a very strong critic of the dominant culture, and people ask all the time, well, what do you want to replace this culture with? And I always say I want to replace it with 10,000 different cultures, each one emerging from its own land base, which is the only way that we can live.
Absolutely.
I want to go back to the talk you did in Vancouver, and then also just what you've written about the mimosa. And can you tell me one or two of the critical responses to your work from within science, and then your responses to those critical responses? Like, one critical response I read was plants can't have cognition because they don't have a central nervous system. So can you respond to that, and then respond to any of the other criticisms that especially annoy you?
Yeah. Well, I had to clarify that they're not so much annoying. I actually learned to find a lot of compassion. So it's been a really good exercise, because I'll make an example first. Imagine your child. You have a child, right? You are the parent. Is it the parent's job, who has had more experience and has, learned about the world for a few more years and hopefully understood something a little bit more than a brand new child? Is it the parent's role to trying to support the child that knows less into trying to understand better? Or is the child's role to tell the parent, no, I only experience my bedroom, therefore the world is just my bedroom? I think that this is obviously an extreme example, but I really felt a little bit like that. I felt like the parent who has been traveling and seeing other things, and even like in the terms of like traveling within the space of my mind, and explored concepts and areas which, yes, they are difficult, because they are asking us to renounce our attachment to all our theories, not just Darwinian theory or whatever, but all of the theory, to then, not to say that they're not correct, but like renounce it just for 1 second and see what emerges. Because in that moment, you might see that what appears to be incomplete is actually complete in itself. It's simply that it looks to you incomplete because you haven't seen it or experienced it or explored it. So what happened with the Mimosa was that what was emerging, a lot of the criticism that were emerging were like, were a little bit on those lines. It's like, oh, I've never experienced this, I've never seen this, and therefore it cannot be. And it's like, well, you know, maybe if you go out of your bedroom, you see that there are other rooms in the house, and you also see that the world is a much bigger place and there is more. And the fact that you haven't seen it or experienced it, should that be enough for you to decide that it doesn't exist? Why don't you just give it a try? And maybe, yeah, you're right, it doesn't exist. But until you go and check it, you can't live on beliefs, because then it's a belief, it's a faith. It's like, I believe in this, and you have no real reason to say so. But, oh, you know, you can believe it, but then don't tell me that I cannot go and explore. So it was interesting because I think that what emerged for me for some of those criticisms, especially the one, if you don't have a brain and a nervous system, how can you? And it's like, well, you know, why should you have a brain and a nervous system to learn? And I have been accused to be anthropomorphic, and I'm like, you must be kidding me, because it's like, who is being anthropomorphic here? You're trying to tell me that a plant must look like me and you for it to be able to learn. So you're telling me that unless the plant is doing exactly as a human being is doing and is using exactly the same system as a human being is doing, which is so totally anthropomorphizing the plant, because of course the plant is doing things as a plant does, then you can't show me that the plant is learning. And it's just like there's nothing lacking. The fact that, let's say, like, we have a beautiful experimental method, which is science. And the scientific method is a beautiful method because over time it has allowed us to explore. And I think that originally, again, I'm not a philosopher of science, but for the little I understand and appreciate of that, is it seems like originally we decided that we had to consider all possibilities, and that's where sort of our null hypothesis was also born from. It's like we have in the experimental method, we use two hypotheses. One is called the null hypothesis, which is basically, it has become like, oh, that is the stupid hypothesis. That's the one that you would never believe that. That's never going to happen. And then you have the alternate hypothesis, which is the one that you really believe that is what's happening. So in the case of the plants, the null hypothesis would be like the plant don't learn. And so you start from there, like plant don't do any of that stuff. And the alternate hypothesis would be like plant do learn. And then you go about and test it and see which one you can reject and which one you can accept. And that's how the scientific method works. The problem is that the null hypothesis, which is a really powerful tool, has become so diminished in its value that instead of being like the null hypothesis should be the one that we really carefully think about, because that is the hypothesis that is the space that allows us to renounce all theories and say, okay, I just forget for a minute about everything that I know and I just pose the question. And then I use what I know to pose the other alternate hypothesis. And often instead it has just become like a sort of statistical tool. It's something that you have to put in your papers because that's what you do. But what happens is that when you actually use the null hypothesis, so you actually ask what you don't know, and you give yourself the opportunity to explore that, then, yeah, that's when you find things that will surprise you, because you are allowing nature, in this case the plants, to show you what they can do rather than what they can't do, which is what we already, we sort of start with, our plants cannot do this. And it's like, well, have you given the plant a chance as a plant, not as a human being, to show what it can do? And of course, what has emerged a lot about the entire discourse and about the entire criticism in Vancouver I thought was really funny. And I had people after the talk coming to, are you okay? And I'm like, yeah, why? And they were like, well, because some of those comments were really aggressive and, and I was like, it's not my problem. I just offered the data. I just offered what I've done. I'm not telling them that they need to believe me. There's nothing to believe. I'm just offering what it is. I just used the scientific method to test a question, and that's what I found. So it's not my problem. It's their problem if they find it difficult to understand, to appreciate, to see, to whatever it is that is, whatever buttons is pushing. But ultimately, what has come down to me, and I am working on this with a colleague because I think it is actually less trivial than it sounds. But it's the problem. The basic problem is a language problem, and not whether I'm speaking in English or some other strange language. But it's like how we use words. Because let's say that we're talking about a bird, and we say, "Oh, the bird cannot fly because it's got broken wings." Then in that situation, we are making an empirical observation. Then the bird, which generally can fly, in this particular case, cannot fly because the wing is broken. So that is science. It's observing from nature, is allowing all possibilities, observing causes, effects, and it's trying to piece things together to understand what's going on. Now, it's got nothing to do, this statement would have nothing to do with the idea that there is a lack of capacity of the bird to fly, It's, the bird generally can fly, just that right now it's got a broken wing. Now, if you use the same sentence and say like, worms or, I don't know, plants or humans can't fly, this is almost like making nonsense because we were not born, we are not made to fly. Like a bird's got wings and that's why they fly, because they were designed to fly. We were not born to fly. Worms were not designed to fly. So you would be illogical in using the language this way. Of course, you are allowed to use it. You can write the sentence, but it makes no sense, logical. Now, the fact that a worm or a human being is got no wings to fly, it's not saying that they are lacking something. It's just simply that, they were never meant to fly, so they never had the ability in the first place. So we shouldn't expect it for them to have it, and there's no lacking, nothing missing. Now, if you take it back to the plant, it's like, well, plants were never designed to have a brain and a nervous system. So they just don't use that. But we need to test whether the sentence, plants cannot think, cannot learn, cannot, whatever you want to put in there, because they don't have a nervous system. And that's what science does. You just test logical statements and decide whether the statement is actually logical or not. And I guess the point is that the lack of something should be tested, and if the concept in itself should not be applied if it's illogical. So why would you expect a plant to have a nervous system and a brain? They were not born like that. But that is illogical if you join it to the sentence, plants cannot learn because they don't have It's like, why? Who said that? Have you tested it? Have you checked? Have you experienced it? Have you allowed the plant to show you what it can do? So I'm not sure if I'm making sense, but I'm just trying to say that we are actually suffering of a form of anthropomorphism, although I've been accused of it. And I think every time we are expecting an animal or a plant to behave and do things as we do them in a human way, we're making a really illogical error. And we should stop making these mistakes, because our way of doing things is a human way of doing things, and it's not better or less than a plant way of doing plant things or an animal way of doing animal things. And So I am exploring, in this case in particular, I am exploring the concept of like, what does the word learning really mean? And if you look across all sorts of disciplines, you will find that there is not really a clear definition in the first place. So there have been so many, argument and criticism about how you can use the word learn and plant in the same sentence. It's like, we actually have to still decide what learn means. And it's interesting because when you look into the literature, and I did a sort of really preliminary search, and when you look for the word learn in a database, the first sort of disciplines that will come up are not the natural sciences or psychology, which is something that I expected. No, it's economics and it's computer science. And it's like, right, so it means that these disciplines are using these words more often than we do. We, like animal biologists or behavioral ecologists. And which is interesting because in both cases you have two systems which are not even biological in nature, like markets. Why would a market learn and a plant can learn? Markets don't have brains and neurons, but they can. And the same with computer science. It's like, yeah, computer science has circuits, and the computer guys have been really smart in borrowing the lingo. So they call neural system like to describe the computer systems, which of course has got like this connotation of like, oh, they got a system that works and looks like our neuronal system, but it's just language, and language in itself is causing so much like confusion, because obviously it seems clear to me that we are actually not quite prepared to explore what we really mean when we use certain words, and it's becoming an important thing to do for me, because I want to understand what I'm talking about when I'm saying plants learn, and I want to be able to define it so that it doesn't have to be human learning, or it doesn't have to be referred to a human way of learning. It's just a unique way that plants use to learn. And of course, it sounds a bit counterintuitive, given that I used an animal framework to test the plant. But I think it is the only way at this stage, until we actually agree on definitions of what we're actually talking about. It's almost like, for me, it felt like it was almost like it was the only way to allow for this concept to be accepted by the wider sort of scientific community, rather than be confined to a specific case in plants and be again pushed in a corner as like, oh, it's something that plants do, but it's not exactly the same. It's not exactly the same, they're right, but it is. Fundamentally, it is. And that's the point. It's like, specifically, we all do things in our own way, but fundamentally, there is no difference and there is no separation on how biology and life in general works. And it's funny because when you talk to our indigenous elders in various parts of the world, for them, this concept, which sounds so almost hippie and new agey, but this concept is so ingrained and so naturally ours, it's so deep that it's like, I think that maybe we are missing something out.
Well, we have like 3 minutes left, and I'm absolutely loving everything you're saying. I think it's so, so wonderful and brilliant. And at the same time, the fact that we are even having to have this discussion kind of breaks my heart. And I keep thinking about how so many indigenous people have said to me that the fundamental difference between Western and indigenous ways of being is that even the most open-minded Westerners generally perceive listening to the natural world as a metaphor as opposed to the way the world really is, and how generally Western science perceives the world as consisting of resources to be exploited as opposed to an entire universe of other beings to enter into relationship with. And so I guess in the last 2 minutes, I want to say one more thing too, which is I was laughing over here when you're talking about the use of the word anthropomorphizing and, projecting that, saying they have to be like humans. Another thing that just kills me about all this is that people like you or people like me get accused of anthropomorphizing, but they use machine language to describe the natural world all the time. And I'm sorry, Can you be more anthropomorphic than to describe non-humans as machines, which is a human creation? That's just nuts. But having said all that,
it's funny.
Yeah. So I've loved everything you've said. There's been so much information, and in the last 2 minutes, what do you want for listeners to take away from this interview, and what would you like for them to, they walk away from this interview and they say, oh man, I heard this great interview today, and somebody says, what was it about? What do you want them to say, and how do you want them to change their way of being?
Well, I think that science is just one viewpoint of the world. It's just one perspective. It's a beautiful one. I think it's a very creative endeavor when it's applied properly. But it's not the end of the story. It's not the story. It's a very predominant story at the moment, but it's not the story. And so I would say go in the garden, go for a walk along the ocean, go to the forest, reconnect with your land and reconnect with the people that knows about your land, that knows about the other stories of your land, and let them tell you the other stories and put all the stories together, because at the end we know different points of view are just different perspective of what the whole thing is. And the more stories you have, the better you're off. And I love stories. So go and find the stories that belong to you, because as you find the stories, whether they are through science or not, you become more human. And you also realize that others don't need to be human either, but they are perfect as they are.
Well, thank you so much, Monica. And I want to thank people for listening, and my guest today has been Monica Gagliano. This is Derrick Jensen for Resistance Radio on the Progressive Radio Network.